Welcome to Transformations in VCE Methods. First, we're going to talk about all the different types of transformations and explain pretty much what they do and how they're represented on these sample parabolas here. But then we're going to break it down and show you step by step what each transformation is actually doing and how we apply it algebraically. So we have dilation, reflection, and translations as our three types of transformations. Now, each of them do something specifically to the graph and do something individual to the graph, but it also is reflected in the algebra as well. But now we're just going to focus on the graph and see how the graph is affected when we have a dilation, reflection, and translation. So we'll start off with dilation here. The colloquial term for a dilation is pretty much just a stretch. So, for example, this is the original parabola here. This might be an example of a dilated graph of our parabola. Now, in this case, what the parabola kind of looks like is that it looks a bit skinnier compared to the original parabola. And the reason for that is because the y value is actually stretching. So we can imagine the graph is just pulled up in the vertical direction, like this way. And you can see that the blue graph is kind of represented like that, where it's a bit thinner. And it's pretty much just stretched upwards. Now you could have it stretched sideways as well. So that would look like a bit wider. So it's going to look something like this. If the original parabola was stretched sideways, it's kind of stretched out away from the y-axis, kind of like that. That's how that would be reflected. So pretty much a dilation is a stretch in some sort of direction. Now, depending on the direction you're talking about and depending on the factor, it's going to change how much it stretches by and in which direction it stretches. So we'll talk about dilation specifically when we get to that part of the video, that part of the section. But for now, just know that dilation is caused by a stretch in numbers by a certain factor and in a certain direction as well. And just kind of to give a bit of it away, dilation is reflected through multiplying of the number. So in this case, what would happen is that the y value is multiplied by, let's say, 2, and that'll double our y value, and that we would call that a dilation by a factor of 2 in the y direction. And then if we had this one here where the x value doubles, that's a dilation by a factor of 2 in the x direction. So that's how they're reflected algebraically. Now for this one here, we have a reflection. A reflection is pretty self-explanatory. You have a reflection in a certain axis. So an example one would be a reflection in the x-axis, because the x-axis is kind of treated as a mirror. So that would be the result of a reflection in the x-axis. So in this case, the y value isn't changing in magnitude. It's just changing in the actual sign of it. So these y values are all positive here above the x-axis. So when you reflect it, the y value is just staying the same number. It's just becoming the negative value of it. So in this case, let's say if we had y is equal to -2, or sorry, y is equal to +2, that would become y is equal to -2 for the reflected graph. And of course, subsequently, if you had negative values and reflected it, they would become positive y values. We actually don't have any negative values in this case, but let's say if the parabola kind of dipped below the x-axis and you reflected it, then that little portion of that arch would go above the x-axis because the negative value is becoming positive. So reflection is it's kind of similar to a dilation. It's multiplying by a factor, but for dilation, it's a certain factor with a numerical value. So for example, I talked about a dilation by a factor of 2. When you multiply the y value in this case to become from positive to negative, you're just multiplying by essentially a -1. So that's what we do when we have a reflection. We just make the y values negative, or we make the certain values negative. You can have reflections in the x-axis as well, but you can see in this case, it actually wouldn't make a difference because our graph is already symmetrical about the y-axis. So if you kind of reflect it in the x-axis and you swap this graph around, these sides here, it would actually become, it would say the same equation and it looks like the same graph as well. So it actually wouldn't make a difference. Now for our last type of transformation, we have translations here. It's pretty self-explanatory. You keep the same shape, but you're just kind of shifting it in the x and the y direction by a certain amount. So you might be able, so you can shift it left, right, up or down. Let's say we shift it to become here, the turning point. What would happen is that your graph will look something like this. Sweet. So the graph would look exactly the same in terms of the shape. It's just the fact that the x value is shifted by a certain amount and the y value is shifted by a certain amount. So in this case, the x value might be shifting in the positive direction by 2 units, and then the y values might be shifting the negative direction by 1 unit. Usually when we describe transformations, we avoid saying left, right, up or down. We prefer to say in the positive direction of the x-axis, the negative direction of the x-axis, or the positive and negative direction of the y-axis. So we kind of use those 4 indicators when specifying the type of translation.